In this problem, we're given another request to find the area inside two functions. So we're given y equals x cubed and x equals y squared minus 2. If this were given to you on an exam where you only had your graphing calculator, what you would have to do at this point is solve this other equation for y. And so that would be y squared is equal to x plus 2, and y would be plus or minus the square root x plus 2. So you would need to graph both the positive square root of x plus 2, and then in a separate y1 or y2 entry, graph the negative square root of x plus 2. So it's a little bit annoying to do this just with the graphing calculator, but it turns out that doing this in terms of y is not actually the most efficient way. Since I have Desmos available to us, I'll just open that up and show you what this region looks like. So you can see here that we have a nice space in front of us defined, and we can find some of the intersection points using the Desmos tools. We have one intersection at 1, -1, and we have another intersection up here at about 1.21, 1.793. So those define the edges of this region. So on the calculator, you would use the intersection function to find the coordinates of that point, which, as I said before, you're going to need if you want to find the edges to know what values to use for integration. So the coordinates of that point are going to be around 1.215. That's a rounded. Actually, what we would really want to do is take the unrounded versions of that and store them in some variable, okay? Because that might come in handy. Now, I am showing you this problem as an example of where horizontal strips sometimes would be a better way to do this. So in order to think that way, we need to take this equation, y equals x cubed, and rewrite it so that it is in terms of y instead. So I can just do that by taking the cubed root or by raising both sides to the 1/3 power. So our integral then, if we are now thinking about this as a horizontal problem, our rectangle is going to look like this. And so we have to think about our top function, which we can see is going to be this, and our bottom function, which is going to be the orange function. The integral then is going to be from the left end, which is going to be the lower boundary, which is y equals -1, up to the y value here of this point. So let's just call that y equals k. And that k value is what I would have taken here and stored using the store function on the calculator. And then we might do alpha k in order to store it in that variable. So now we write this integral. Our top function is the y to the 1/3, that's the green, minus the bottom function, which is the quantity y squared minus 2. All of that multiplied by dy. Now, since this is a problem that you would be given on a calculator active section, once you have this, and once you establish that k value is this 1.793 decimal that goes on for a while, you are permitted to then just use the calculator to evaluate this integral. I'm going to use Desmos because I've already set this up to do that. So if you set up the integral using that 1.793 number, again, the unrounded value is what you want to use there. You get a value that is to 3 decimal places, 4.215. So that is what we would put as our answer for the area of this region.